Welcome back, smart mathematicians. We are doing question 7.5, which is the last part of question 7. So let's read the information from here again because the top part is just the same. T is a point on F between B and G. Oh, we didn't. Okay, we don't need that one. A straight line G parallel to AE cuts F at K and R. Calculate the x coordinate of R. Okay, so we need to have a picture of this line G. So we're saying it is parallel to AE. So it means it's a line which is like this. This is line G here, which is parallel to AE. And then it cuts F at K. They say this is K here. And then at R. This is R there. And then we're given the coordinates of K, which is -3 and 9 there, -9 there for the Y coordinate. Right, calculate the X coordinate of R, means the other point of intersection. So if you check here, K and R are points of intersection. And then how do you find the coordinates of the points of intersection? We have to solve the equations of the two functions simultaneously. We have the equation of f of x, but we don't have the equation of g. So it means we have to find the equation of g. Okay? Right. Let's just do that. Right. We'll start by finding the equation of g. Let's draw the line here. Let's just assume this is the line G. And then this is K, -3, -9 there, then that is R there. Okay, so now we have the gradient of G. Do you know that? Since G is parallel to AE, their gradients are the same. So we can say the gradient of AE is equal to the gradient of the line. See that? So it means the gradient of the line is also in 1/4. Remember, we found the gradient of AE, we said it is 1/4. So we can use y is equal to mx plus c, or we can even use y minus y1 is equals to m, the gradient, x minus x1. We'll use both, okay? Let's start with y is equal to mx plus c. So we can substitute our coordinates for k there and our gradient. So -9 is equal to 1/4, then times -3 plus c. And then -9 minus, this is -3/4. If you check, if you bring it to the left, it's going to be plus 3/4 is equal to c. You can put this in the calculator. You'll get that c is -33/4. Okay, meaning that the equation of the line is y is equal to 1/4x minus 33/4. Right, we said we can also use this one. We can say this is y minus -9. What is it? Minus -9 is going to be plus 9 is equal to m, which is 1/4. Then x minus -3 is going to be plus 3. Okay, then we can say y plus 9 is equal to x over, we can write it like this, x/4. This is just same as 1/4x, then plus 3/4, and then we can bring 9 this side, becomes y is equal to 1/4x, and then plus 3/4 minus 9. And then you can put this in the calculator. It will give you -33/4. So y is equal to 1/4x minus 33/4. Okay, so now we have the gradient of g and the gradient of the function f of x. Remember that, okay? So we can solve these two equations simultaneously and find the coordinates of k and r. So this is going to be our checking point because we must get -3 for our x. One of our solution must be -3. Okay, let's just do that now. So we have the equation of g, which is y is equal to 1/4x minus 33/4. And then remember, we have the equation of the function f of x is equal to what? we have it is x squared minus 2x minus 24. Okay, right, you can check that. You have it there. So we can equate these two functions because at the points of intersection, they are what? They are equal at k and r. So we can say here, therefore, at the points of intersection, f of x is equal to g of x. So it means x squared minus 2x minus 24 is equal to 1 over 4x minus 33 over 4. Then what can we do here? Multiply everything by 4. The LCD there is 4. So it becomes 4x squared minus 8x minus 96 is equal to x minus 33. Okay, let's write this in standard form. So it becomes, transpose this, you can also transpose that. So it becomes 4x squared minus 9x, then minus 63 is equal to 0. That is in standard form now. So we can, if factorization is giving us problems here, we can use what? We can use the quadratic formula. Remember, x is equal to negative b plus or minus the square root of b squared minus 4ac, all this over 2a. Okay, then we can substitute x is equal to negative b, is negative minus 9, negative 9 plus or minus the square root of negative 9 squared minus 4. Then a is 4, then c is negative 63. Then all this over 2a, which is 2 times 4. Then you can put this in the calculator. You get that x is equal to 21 over 4, or x is equal to negative 3. Okay, you can even use factorization. X plus 3, these are the factors. Then 4x minus 21 is equal to 0. And then you get that x is equal to negative 3, or x is equal to 21 over 4. Right, remember, we managed to get that, we know that k here is negative 3 and negative 9. You see that? So this is negative 3 we're getting here. So it means the x this side for r is what? Is the one which is 21 over 4. But we don't know the y. But we just asked to find what? To find the x coordinate. Therefore, the x coordinate of r is 21 over 4. Okay, but if you're asked to find the coordinates of r, then you can substitute 21 over 4 into one of the functions. They can substitute into f, you can even substitute into g. You'll get your y coordinate. Okay, so that's what you're supposed to do there. We're going to meet when we do question 8.